Hello, everyone, and welcome to video 2 of our ROS2 crash course tutorial series. ROS is the robot operating system, and in this video, we're going to be getting hands-on with our code, getting hands-on with our integrated developer environments to actually program some of the first features we're going to interact with as part of ROS. And we're going to be covering publishers and subscribers, so we're going to be creating our first nodes within a ROS2 environment. Now, if you don't know what the robot operating system is, when I say ROS, then you should go back to video 1, where we cover it in more detail and cover on a high level what you can do with it, what sort of tools and technologies you would want to be familiar with if you want to work as a robotics software developer or as a robotics researcher that would use tools like ROS. So if you're a little lost on what's going on, go back to video 1 and see if this is something that you want to learn more on. That was more of a high level video. This is going to be, again, the first video where we get hands-on with code, hands-on with our environments. Now, today we're going to be covering navigating a real ROS2 workspace, what it looks like when we're working within our IDE, within our virtual environments. Then we're going to create our first node. We're going to create our first publisher based on that node, which the publisher is a form of a node. And a subscriber is also a form of the node, and we're going to create a subscriber for that publisher so that we can read the data streamed by that publisher. And by doing all of this, we're going to be covering some of the fundamental Linux commands that you would need to know as a robotics developer. You don't need to know Linux to follow along with this tutorial series. Once again, we just ask that you have some knowledge of Python so you're not completely lost as to what we're doing when we're programming. You don't need to know a lot of Python, just enough that uh, you could, at least have an idea of what's going on when we're writing code on a screen or just navigating a script of Python. But as far as Linux goes, it's one of those tools that you should know if you want to become a robotic software developer, but you'll see enough to navigate at least this tutorial series and navigate a ROS2 environment just by following along with this video. To recap, a publisher subscriber is a form of a communication model that's the foundational building block of ROS2. It comes from DDS architecture, which we talk about in video 1. And what it allows us to do is stream data across our robot. And the nice thing about publisher subscribers coming from the DDS model is that they allow us to not only stream raw data, but also stream data types and data structures. And we're going to stream a data type today over our publisher connected to our subscriber. Now, everything that we cover in this tutorial series is following this reference book, which you can get for just $20. You can get a Kindle or PDF copy, which is what I'm going to be using throughout this tutorial series. You don't need to buy this book to follow along, but by buying the book, you get access to the GitHub repo with all kinds of reference code, which we are going to be using in this video series. And you also get access to reference code that's actually within the book. And moreover, um, I'm going to be more so just covering some high level concepts. I'm going to be actually implementing some code on my screen. I'm using a different virtual environment than the book uses. The book actually goes through a full installation process of how you would get ROS2 on Linux in like a virtual environment, like a formal one. We're using a web simulator that does a lot of that in the back end for us. If you want to watch video 1, you'll see the process of how we go about doing that. But rather than following that full installation process and debugging process that's usual with installing ROS2, we're just using a web simulator where you create an account, you log in, and you can create a working virtual environment that has everything already pre-installed for you. And we're just doing that to expedite the process of getting into learning ROS. But again, some deviations from the book. We're not just following this verbatim. I'm not going to follow every single line in the book. I'm just going to skip to some stuff that I think is important for you to know right now. But if you want to dive deeper into it, then you want to get the book. And once again, no installation is needed to follow along with this tutorial series. We're going to be doing everything on the Construct Sim, which is this web simulator. And let me actually go back to the home screen. So you can see if you create an account on the Construct AI, this site, you can go to My ROSjects under the develop category. And um, we covered this in video one. I'll just briefly go over it again. If you wanted to create your virtual environment, it's as easy as clicking on just this, create a new ROSjects, go to ROS2. We're using the Humble distribution. You click I will create mine for your simulator, and then you just give it a name and you click create. I already have one for this tutorial series, so I'm not going to do that. Mine is just this one. Um, you can see all of your different demo virtual environments in that page. And while that's opening, I just want to show briefly. This is the book that we're following. I just have my PDF copy. A lot of the contents from this video are coming from chapter 2. Once again, I'm not going to just cover this line by line, but I will be referencing this to grab some commands that we're going to be running on the Linux terminal. And then, once again, you can also get your GitHub repo for reference code if you purchase the book, and you can navigate through the GitHub repo. You can find reference code, like here's the first node that we're going to create as an example. Um, we can copy and paste that in. We can, if we try to follow along with the book and write up some code and our nodes aren't working, or, we start needing to debug, we can always reference this code and see, did we miss something? Is the code used by the author of the book different than what we've written? So it's a pretty neat resource. Once again, please support the author by getting the book. I'm not an affiliate, just they did some really nice work creating that book for us. And now that we're in that virtual environment, if by default, if that IDE hadn't opened for you, this is probably the first thing that you would see if you were from creating a fresh install of your virtual environment. Um, you would likely see this default page open up with asking you for a README for documentation. You can ignore that for now. We're going to open a code editor, which is an integrated development environment. By default, it comes with a Visual Studio Code, which is great because that's what we'll usually use for robotics development in C++ and Python. Um, you can navigate it just like you would in like the Windows version of VS Code if you've used that before. The nice thing about this simulator is it already comes pre-populated with a lot of ROS packages, which we'll look at that in a moment. And it also comes with a workspace pre-made for you, which is this ROS2 workspace folder, which I have highlighted. You can see other workspaces. We're going to be using the ROS2 workspace, which is the defaults. And it's pre-populated with some of that folder architecture that we talked about in video one: build, install, log, and source. Source is where we'll be writing code. Right now, source is empty. That's all right. We're going to create our packages in source. And one of the nice things, we talked about how we're going to be using Linux. Everything in this virtual environment is running on Linux. We're just accessing that through the web. And in this web shell, we can actually open a terminal, which would be, if you're coming from Windows, that would be like command prompt. We're opening a terminal to run some Linux commands to navigate our different folder architecture, run packages, and a lot of the commands that we use in ROS are going to be run through this terminal. So some of the fundamental stuff that you should know for navigating Linux, this ls command allows you to see what folders are in your current directory. Right now, if you see user and then a tilde with the $sign, and then there's nothing after that, that means that we're in the root directory. So to show an example of getting out of the root directory and what that means in like a hands-on way, we can use CD to navigate into different folders. So we know that from our IDE, from our kind of like a regular folder structure that you would see in a computer, from a GUI, you would have these three folders and you can navigate into them. You can navigate the folders in that. You can navigate the files in that. Similar on the Linux terminal, you can see with ls which folders are in your current folder or directory. And then using CD, you can actually navigate into those directories. So by using CD and then the name of the folder slash directory that we're trying to get into, we can get directly into that directory. Also, by using cd dot dot, we can navigate back out one level. So it would return us to the previous level. You can also use cd ROS2 workspace, and we know inside of the ROS2 workspace folder that there's the source folder. We can type that all in one go and go directly to the source folder. And if you want to go all the way back to the root node, if you do cd dot dot, it's just going to back out one level. So you can see it only backed out of the source folder. If you wanted to back out all the way to the root folder, you would do cd tilde forward slash, and you're going to get all the way back to the root of your computer. Now, this is a lot of the fundamentals that you need to know. We're going to be using this a lot to access the actual workspace, initialize it, build our packages, um, run our source install setup bash command to actually set up our environment variables, and you'll see that in a moment. And then we can run our actual packages using different commands on this terminal. So this is going to be an important skill to pick up throughout the process. But once again, you can just follow along. We'll teach you along the way. Now, once again, we're not just going to be going through the book verbatim. There's a lot of commands that are just for setting up your ROS instance from scratch. I want to show you that we already have a lot of stuff pre-installed. By running, let me run that again. So by running ROS2 package list, you can see all of the packages that are installed currently on your ROS2 instance. You can see we have a whole lot because, and some of these aren't default packages, but by working with the Construct Web Simulator, they do a lot of the work for us, so we can just get right into developing our robots. Now, once again, we've already we already have a workspace created for us. We don't need to follow some of these commands. That being said, this is Holcon build. We're going to navigate into ROS2 workspace again, into that directory. And then by running this colcon build command, we're going to initialize any packages that we've created in our source folder. So any code that we've written, any packages that we've written to control our robot, first we'd need to build them using this command. Now, if I run it, it's going to tell me that 0 package is finished because there's nothing in my source folder. But once we create something, you'll actually see that in action. Similarly, let me I'll just write it myself. We're already in the workspace folder. Source install setup bash. This is going to reference our setup files within any packages that we create and set up our environmental variables for actually running any code that we create. So this is going to become important in a moment. Once you build your packages, this is going to be the main command that becomes important because within ROS2, we're not just going to be working with our one terminal. One of the nice features in this web simulator is that it already comes with the option to create multiple terminals and run them side by side because we're going to need to do that, and you'll see that once we create our publisher and subscriber. But every time that we create a new terminal and try to run another package on it, we're going to need to reset up our environment variables for that terminal before we run anything. Otherwise, it's not going to work. So that's going to become this. Here, let me remove the workspace because we're already in that folder. This is going to become a command that you're going to be very familiar with, and so familiar that I recommend, like I have this reference code notebook. You can use Jupyter notebooks, you can use OneNote, you can use anything that you want to kind of hold that code for you. If in fact Jupyter notebooks is pre-built into this, it's the documentation section that we hit earlier. But I really recommend having some of those common commands somewhere for you to access. You're not constantly navigating back and forth for documentation, especially stuff that's like you're going to use a lot, like this setup bash file. Um, I really recommend just having that for quick access. You'll see some of the other ones that you'd want to know throughout the video series. But just so you know, just so you don't have to navigate as much. Eventually, just like you saw, I typed this in, you'll remember a lot of these commands, but for now, while you're learning it, just have like a reference. Now, we're going to create our first package. So in order to do that, we're going to, here we go. We're going to grab this code from the book. You can see, I mean, you could just follow along by writing it directly. Here, let me expand out the terminal so you can see the full code in one line. This is ROS2 package create. Oh, wait. Before we do this, sorry, go into the source folder. And now you always want to create your packages within the source folder. So now we're going to create a package. We're going to call it of a build type where we're using Python, because you can use other languages. And then we're going to call this package minimal package. And when I run that, it'll run. And now when I navigate through the source folder, you can see I did that all in the terminal, but I can still navigate on my IDE, like a more common setup. And you can see that folder structure that we talked about in video one. You see your setup.py file, you see your XML file, and you can navigate your environmental variables, you can navigate your dependencies, you can navigate your actual code that goes into the minimal package folder within the minimal package folder. And we talked about why that's important in video one. But when we create any code, it'll be within a package, and there's two ways to create an actual file that we can work on. One way is using the IDE, another way is using the terminal. First, we're going to cover the IDE. We're going to create our first node. Um, so I'm just going to skip some steps that aren't totally necessary right now. Um, so this file is going to be called minimalnode.py. Just copying that here, save myself some time. So in the IDE, we can navigate our folder structure. We can go notebook workspace, sorry, ROS2 workspace, source, minimal package, minimal package. And once we click on this minimal package folder, so it's highlighted, we can just click this button at the top to create a new file. We'll call it minimalnode.py because it's a Python file. And now we can type Python code in here. For the sake of keeping with time, I'm just going to grab the code and discuss it. So once again, in the GitHub, you can navigate through and find a lot of the reference code. But let's talk about it. We're importing RCLPy. That's our backend Python translator for ROS. We talked about that in video one. We're going to import node, uh, which is a data structure used in a lot of different data, in a lot of different programming languages, including Python. And that's going to be the fundamental class that we use for creating nodes in ROS2. And within this file, um, what we can see is this really important command, self.getlogger.info hello ROS2. This first node that we create is going to be like the hello worlds of ROS. And the way that this script works is that the main file is what runs. First, we initialize our API for translating Python for ROS, and then we're going to create our first node with this minimal node equals, and then a minimal node initializer class. So we're creating an object of minimal node class. Um, this is object-oriented programming, so this is why I mentioned you should be a little familiar with Python. I'm not writing a lot of this stuff from scratch, but just so you know what's going on. This is an object of a class. And when we initialize that object of a class, we're calling this your created initializer in it. And whenever an object is created, it's going to run this script. So as soon as this line runs, this is the code that's actually going to be running. Like we can interpret this as our real program. And whenever we run this command is going to run as part of it because it's part of the initializer for that object. So um, on the console, we're going to see it say, hello, ROS2. And right after, it's just going to destroy the node to not keep that in memory. And that's really the gist of creating our first node. This is going to be our hello world script. So you can save this by just clicking Control S, or you can also go to File, Save. By default, there should also be like an automatic saving every few minutes sort of thing within this virtual environment. Um, but in order to actually run this command, sorry, in order to actually run this package, we need to edit our setup file with this entry points, console scripts, minimal node, this line right here. Um, this is going to actually allow us to reference um, this package, this file within the package as minimal node. Minimal node. It's referencing the location so that ROS actually knows where to find it and what to run when we do the ROS run command. So once again, you just want to click save. And now we can go back to our terminal. Let's go back to the workspace because we don't want to do colon builds or source install setup bash in the source folder. We want to do that in the workspace. So let's do colon builds. You can see that this time there's one package instead of zero. And now we can do source install setup.bash. So now we set up our environment variables, which are here. And finally, we can run our package. Oops, let me lower this. And that's going to be just on the terminal. We can run our package. And look at that. It says hello world. Hello ROS2. That's our hello world for ROS2. Now, um, it's that easy to create a node. And this is kind of the foundational setup that we're going to use to create both publishers and subscribers. So in order to create a publisher, we're going to change it up a little bit. For creating this publisher, see here, we're going to create another package. So we're going to go back into our terminal. And we're going to go once again into the source folder because any package that we create, we're going to want them to be in the source folder. And you can get this in the book. I just wrote it out because I've been having some issues copying and pasting directly when things get so long. But we're going to, once again, create a package. We're going to call it pub_sub, as in publisher subscriber Python. And then we're going to call it a build type of Python so that we're using Python code. And for some dependencies, we're going to reference standard messages, RCL_py. And the reason we do this, you'll see it in a moment, is we can hide that minimal package folder. You can see this new pub_sub_py package in source. The reason why we ran those additional dependencies is it's going to auto-populate this script for our dependencies in the XML file. And once again, we talked about XML files on a high level in video one. But if you didn't run that dependencies section of the code, if you just created your package, you could always just add under license whatever dependencies you need, and that'll work fine. Now, in pub_sub, we're going to create our first publisher script. And in order to do that, we're going to try creating the folder directly in the terminal. Sorry, and creating the file directly in the terminal. So you can see the process of doing that. So you're not just navigating through the IDE. I recommend using the IDE, especially while you're learning, but just know that this is an option. And as a software developer in robotics, sometimes you're going to need to work on environments that don't have many resources. Like I'll give a common example. You might buy one of the cheaper models of like the older models of Raspberry Pis that have less capabilities, less processing power. And on those, something to know is that running a GUI is really resource intensive. So you don't want to be burning through all your resources just to run a GUI. A lot of times you might have to program robots directly from the terminal. So we're not going to cover that in detail here, but just Just know that the reason we use Linux is a lot of these features are supported and are easy to do. There's established ways. This is kind of like the default mode of operation within Linux. And if you were to work in one of those environments, you could just work directly from the terminal. You don't have to navigate this nice GUI. But once again, I just recommend doing it. I'm just going to show how we would create a file in the GUI so you can learn a little more about Linux. So we're going to go into our pub/sub folder. We know that our actual code goes into another folder with the same name. Once again, referencing what we talked about in video one. And then by running touch, we can create a file. And we're going to call this file, I'm just going to reference real quick. Uh, we're going to create this sinusoidal signal as our publisher. And we're going to call it sine wave pub.py. And you can see when we run this command in pub/sub/py, we can access our sine wave publisher. So once again, I'm just going to grab the code from the GitHub. So this is chapter 2. We're in pub/sub/py, and we can grab our code from here and then we'll discuss it. And you can always edit this code. You can play around with it. Like I recommend, print another message with the hello world style first node that we created. Now in this one, um, you can you're setting up, some of your imports, and then we're creating this class, which is also a node. So both minimal node, sinusoidal publisher, both of these classes are nodes, and we know that because they're inheriting the properties of node. Once again, this is from object-oriented programming. And within that, when we initialize our sinusoidal publisher, we're telling it that we're going to be sending a data type of a float 64. So once again, we talked about how we can send different types of data types, data structures across publishers. In this example, we're going to be sharing a float 64 data type. And in our actual code that's run, we're going to create an object of that sinusoidal publisher class. And then we're going to run this spin command, which basically just tells it to repeat running that code and publishing it. So continuously um, output information. And one thing to know is that we're running this timer section so that every few milliseconds we publish the next piece of data. Otherwise, it's just going to publish as fast as it can. And um, we don't necessarily need that. But we can change this interval. So you can, in terms of changing this code to experiment with this code when you're working on it on your side, you can try changing this value, the frequency over here, to see how that impacts your code. And we'll see some, what the actual ramifications are of running this code are in the terminal in a bit. And another thing you can change is this amplitude. So this is the amplitude of our sine wave. We're going to be creating a nice sine wave like this to publish, and our subscribers will be reading information that's basically what is the current height of the sine wave across different points in time. So you can change the amplitude, you can change the frequency, and see how that impacts the values that you get out. But basically, that's what we're doing here in this publisher. You can save this, and once again, you need to go to your setup folder. Sorry, your setup.py file in the test folder. Sorry, in the pub/sub outer folder. And next, you want to just grab this script so that ROS2 knows what you're referencing when you run the ROS run command. You're referencing as sine wave pub. You're referencing that file under pub/sub/py under this folder. You're referencing that sinewavepub.python file, which is this file right here. So you want to save that. Just gonna add a comma. And using Control S to save. And now we go back to our terminal. We can go to cd roots, cd ROS2 workspace. And once again, we want to build our packages from scratch because we just created a new package. So we need to build them within our ROS workspace. So that's colcon build. And now we have two. Now we had zero before, then we had one when we created that minimal node. And now that we have a pub sub package with our publisher and subscriber, we have two packages. And we also have to run source install setup.bash because we have that setup.py file that we have some variables that we need to initialize in our workspace. So we need to run that. And finally, um, we want to run the actual ROS2 run. Let me just copy that from here to save some time. We actually want to run this ROS2 run pub sub pi and then the name of the file that we want to run. And the reason why we're not seeing anything is because this isn't outputting any information to the console. It's outputting this to like any communication system, like a subscriber that's connected to this node. So we can't see this on this terminal. But in order to see it, once again, if this was our first terminal, we can just create another one. And we can actually see our different nodes that are running through, um, whoops, let's run this command. Through this ROS2 node list command, we can see sinusoidal publishers running. So something is being published across the ROS2 network. And if we wanted to see what's being sent over this um, publisher, we can actually see some information on it by running this ROS2 node info slash and then the name of our node. We could see what are current subscribers, which there are none because we've created none. We can see current publishers. A lot of this information just comes from RCL Pi. So it's the API we're working in the backend. But if we were to connect to that data, we can actually see that float64 value that's being published right here. And I know this isn't super practical yet, but we're just seeing that like our publisher is working. So the next thing we want to run is this ROS2 topic echo, ROS2 topic echo, and then sinusoidal signal. And by doing this, we can actually see what's being streamed from our publisher across the ROS2 network. So now we can actually see the values coming from a sine wave of amplitude 2. So it's going to go to -2, and then it's going to bounce back to +2, and then bounce back to -2, following a sine function. So we know that our publisher is now working. And we can also see one thing to know, whenever you run something, like you can see we're no longer in our command line to run different commands. It's just doing something in the backend. So you see this black area. Similarly here, there's no more of the user colon and then what directory we're in. We're just seeing data now through this terminal. If you want to stop this and go back to your command line, you can click Control C and it stops whatever is currently running. We'll talk about Control C more in detail in the future, but just know that this is a way that you can go back to your command line if you want to run something else. And we can also do ROS2 topic hertz to see the frequency that's, it'll just once again continue to pick up information from the publisher. And we can see that every roughly 100 milliseconds, which is what we defined going back to our publisher, that's what we defined right here and right here in the frequency. Roughly every 100 milliseconds, we're getting some data from the publisher. And we can also see here that it's not perfectly every 100 milliseconds. There's standard, it's like a around a normal distribution roughly. There's a standard deviation and all that. Now, the last thing is we can see a list of the current topics being streamed over our ROS2 network. So here's a sinusoidal signal. And there's also these default, this is usually at the start of any ROS2 instance workspace. You can see these parameter events on ROS out topics. So this will always be here. And any other topics that you create through publishers, and then you run those publishers, will also populate this area. Right now we don't have too many, but once we're running an actual robot, we'll probably have a lot here. So this will become pretty dense and we'll read through them. But yeah, you could just see your newly created published signal here. So that's pretty neat. And we actually want to do something with that data, right? So it's nice to see the data as this like sine wave plotted out. Um, So we've talked about how publishers just stream raw data and then subscribers take that data and do something with it. So the next thing we're going to do is we're going to create a subscriber that actually takes that data from the publisher and creates this nice plot of a sine wave. Something to know is that we're going to be using the matplotlib folder. So something that's not covered in the book. Normally you would install this. I'll talk about that in a bit. But it comes pre-installed in this web simulator. But one of the downsides of using this web simulator, they seem to have two different installations um, of matplotlib, of NumPy, which we need to remove one of them because if we have both running, it'll create some conflicts when we run our actual subscriber. So before we continue, the first thing we're going to do is we're going to pip and uninstall matplotlib and let that run. Oh, interesting. Found existing implementation. And then let's try pip uninstall numpy. Okay. Well, we'll see that when we get to that. But um, with that, we can create the subscriber. Just a debugging step that I had to run into earlier. But with that, we can create the subscriber. So go down to here. Uh, we're going to call the subscriber sine wave sub and plots. So we're going to go to our pub sub folder, sine wave sub plot. We're just gonna have that E because they missed it in the book. There's a few typos in the book. And then we're going to go to our GitHub, grab the code for that subscriber, 7 plots, and then we'll talk about it. So, similar idea, we're just importing stuff. We're creating a class that inherits from node to create a subscriber. So again, changing the initializer a bit so we can receive information. And then we have a few different functions to log. And this is all kind of getting into the rate at which we receive information throughout our node, which matches the rate that the publisher is sending information out. One thing to know when we just copied this in, this is just an issue of the white space in Python. So you can just delete some of these tabs and repress enter, and that'll correct that error that popped up. And at the end here of this, within the different methods that we have, within sinusub method, within the log data method for this class, we have our actual code from matplotlib to take that data from the publisher and plot it. So this sinu data, which you'll see throughout the log data folder. We're gonna basically create an empty array. We're gonna append values from the publisher. So as we receive values from the publisher, we're appending them to that array. And then we're taking that array and putting it into a plot. So an X and Y plot, which Matplotlib will handle that in the backend for us. We're just calling that API to do that. If you're not familiar with Matplotlib, it's a pretty commonly used package for data analysis in Python. So something neat to learn for data analysis throughout your robotics project would be Matplotlib. But once again, you don't need to know that right now. You could just run this code. And here's our actual main folder. It creates an instance, an object of that sinusoidal subscriber class. Then we're starting it and we're running spin on it so that it continuously picks up information and plots it, right? Now that we have this, we can save it and we can go to our terminal. We can go to, let's stop that publisher while we're doing this. So Control C once again to stop a publisher. And then we can go into our workspace, ROS2 workspace. We have to run colon build again because we've added something to our package. So we need to rebuild our package. And then in order to actually run this, oh, wait, before we can run anything, so we've created our file, and we still need to add it to this setup .py file so that ROS2 can um, actually find it and run it. So let's see here, right here. So we need to grab the code to actually be able to do that right here. And now we can reference sine when we run ROS run, we can reference the package as sine wave sub to start up our subscriber and pick up information from our publisher. Sorry, I just paused the recording because um, once again, there's some typos in the book. So our build failed because we left this hyphen in this area of setup pi. So we just need to delete that right before main. We can save and now we can go back, go to the ROS2 workspace, just restart from scratch. You can close your terminals. So let me do that from scratch. Your web shell, cd ROS2 workspace, and then we can run colon build. So simple typo can make your program not work. If something isn't working, don't freak out. There's probably a typo somewhere. Please let me know in the comments if you find anything like that. I can try to help you out. And next thing you know, that runs. You can run source, install, setup bash. You can once again run our publisher. This is a nice thing once we have all of our packages created. It's pretty neat because our publisher is running and we don't have to rerun in the next terminal. We don't have to rerun colon build. We can just directly go to source install setup.bash. Oh, wait. First you go into your workspace, ROS2 workspace, then source install setup.bash. And the reason why we can skip colon build, again, we've already built our packages. And now you can run the same thing again, ROS2 run pub sub pi, which is our package, and then the subscriber. And this should create, it'll take a little bit because it needs to open up matplotlib. It needs to open up the GUI so we can see our sine wave. So it's starting to gather that information. And in a moment, we should see our plot pop up. So I'm leaving this in the video with the little troubleshooting step because once again, you're gonna run into situations where you need to troubleshoot as a developer. And just like that, you can see my code didn't run on my screen because I left in a hyphen. So it's little things like that. Um, don't freak out. Just If you don't know what to do, just leave a comment. I can try to help you with that. But with that, we can see we had our publisher sending out that sine data, sine wave data. It had an amplitude of 2, which here, let me expand this out a bit so you can see it. So you can see the middle point is 0, and it goes from -2 to 2. And our subscriber was doing something with that data. So it gathered that data, put it in an array, and then it plotted the time versus the height of the sine wave, which was the data that our publisher was sending out over ROS. So with this, you can see a simple example like that sine wave could be data coming in from a sensor. Oftentimes they're coming in the like a waveform. So you can publish that over the ROS2 network, and then you can create different subscribers that um, latch onto that data and do something with it. In this case, we're plotting that data, but we could do other things, and that data could be in other forms. So we could do a lot with publishers and subscribers. So I want to thank you for watching this video. And in the next video, we'll cover our client server model architecture that we talked about in video 1 and what that looks like implemented into code. We'll we'll play around with that a bit. And I really recommend, just to kind of learn some of these concepts a bit better, you can follow along and also you can edit some of this code and play around with it. You can go to your publisher once again, change the frequency, change the amplitude. You can go to your minimal node, that hello world script we wrote. You can change the info that you're sending to your console. And you can also go to your subscriber and you can change stuff about this. Maybe if you know Python, you can implement something else that you want to do within Python. Or you can change the rate at which you're receiving information and plotting it, and you can see the impact that that might have on your code. So I recommend you play around with this code, and we'll see you in the next video.